So, my dear students, let's see right now we are going to see what benefit you people are going to get for your NEET 2026 from this IIT mains paper of April, right? So, let's solve this paper and I will let you know whether organic chemistry was more over here, inorganic or physical, and I will let you know that what type of questions they have asked, the numerical based, the tough numerical based, or the statement based. But first of all, let's see this question. Let's focus on this question. Now, my dear friends, if you see this is a question of organic chemistry, if I talk about Finkelstein reaction, Finkelstein reaction, that is halogen exchange. So see, from alkyl halide, haloalkanes, haloarenes, they have given both the two questions and I was telling you all these things. So Finkelstein reaction, NAI acetone, A.S.P. A.S.P. only one option, but let's see. Schwarz reaction, fluorides, some specific metal fluorides. I have given you the code, फ्लोरिडा में सबको आज हो गया. So B is S. B is S. Now, if you see about Sandmeyer reaction, so D is R. Anything if you know, D is R, D is R. So, my dear students, the correct answer is, just you do let me know. I have told you each and everything. Now, you can definitely let me know the answer. If you simply see from Schwarz reaction, that Schwarz reaction is this. That means B is S. B is S only in one option. B is S is given. If you simply see Sandmeyer reaction, then Sandmeyer reaction D is R. In two options D and R is given. So it can be a problem. So Finkelstein reaction will decide. So this is your answer. Now let's move towards another question. And this is from coordination chemistry. My dear students, this coordination chemistry question can be easy or it can be tough. So you should know what science teacher, very crazy man, felt cold in night with cousin. Now focus over here. If you don't know this science teacher, very crazy man, and if you're not having practice of this science teacher, very crazy man, felt cold in night with cousin. My dear friends, this time, let me please focus. This time, the maximum percentage questions they have asked from inorganic chemistry. And what type of questions they have asked? Let me tell you. After this question, I will tell you. Now, my dear students, if you see over here, the Bohr magneton is given. Once you try to find out the number of unpaired electrons, and to find out number of unpaired electrons, you should know the atomic number 21, 22, 23, 24, 25, 26, 27, 28, 29 and 30. Now cobalt, we know that. What is the atomic number of cobalt, my dear students? Cobalt is over here 27. So just reverse it, write down 7 2, 3d7 and 4s2. Now cobalt is with water. One more thing, the spectrochemical series I have told you with water, but you see this is cobalt 2 plus. Otherwise with cobalt 3 plus, water act as strong field ligand, but here it will act as weak field ligand. So cobalt 2 plus, so 2 electrons gone, and 3d7. If I draw 3d7, 1, 2, 3, 4, and let me fill the electrons. 7 electrons, 1, 2, 3, 4, 5, 6 and 7. It is having 3 unpaired electrons. So the Bohr magneton value, because n number of unpaired electron is 3, so something more than 3. So definitely 3.87. Now if you talk about chromium, chromium is actually 24, so it is 3d 5, 4s1, but 2 electrons gone, so 3d4, 4 point something. So 4 point something is one option. My dear friends, now in this way you can find out your answer. Now, is it clear? Directly if I talk about manganese, manganese is 3d5, 4s2, gone 5, so 5 point something. 5 point something is over here. Now, my dear friends, another question. If you see, and this I have told you and taught you that D block, KMnO4 and potassium dichromate. 2 days back I made one video that what is required from D block and F block. So see direct question. How many moles of potassium dichromate are required to oxidize ferrous to ferric? I've told you over there that N factor of this K2Cr2O7 is 6. How to find out? If you see that chromium over here, chromium Cr2, two atoms changing from plus 6 to plus 3, green color compound. So the N factor is, its N factor is 2 into absolute mod of final oxidation state minus initial. So N factor is coming 6. And ferrous is converting from plus 2 to plus 3. So its N factor is 1. Ferrous N factor is 1. So they are saying how many moles of potassium dichromate are required to oxidize ferrous to ferric. My dear students, it's very simple that see, there are 3 to 5 methods by which I can solve this question. Let me tell you, my dear students, let me take a page. Let's take the page. I have added one page, and if I add one page, let me say, okay, so here I don't know how to add the page, so I will do one thing, that let me explain where I can explain, kids. Let me get some space. Let me see that I have page. Yeah, I got it. Thank you. Thank God I got the page. Now, my dear students, if you see, then we will get NNF is equal to NNF. What is this NNF and NNF? Let me tell you, my dear students, if I say this is about ferrous and this is about K2Cr2O7, this is known as law of chemical equivalence. N represent the moles. Here this N means moles, and that means valence factor. So they have asked in the question, what was the question? Just see once again. If you look the question was, how many moles of potassium dichromate are required to oxidize ferrous to ferric? Now, my dear students, their data is missing, because they should have given 1 mole of ferrous to ferric. Then only we can do, because in both the two cases, if moles are missing, we cannot do it. Now, let us suppose ferrous 1 mole and its N factor is 1. Its moles we don't know, but its N factor is 6. So the answer is N is equal to 1 by 6. I hope this is very much clear to all of you. So data was missing. So if something is missing, we can take just 1. Now let's deal with another question. This is solved and sorted. Now see, what is the bond angle of chromium, oxygen, chromium and dichromate? This I have taught you, and direct question we have got. So you see it's roughly 126. So options are given over there. Now how to do it, my dear student? Just see how to do it. This oxygen is having 2 lone pairs. So valence shell electron pair repulsion theory, but these two are very bulky groups. Now, my dear students, structure is somewhat like water, but in water there were 2 hydrogens, and hydrogens बहुत छोटे होते हैं बच्चा, बहुत छोटे होते हैं, तो they are 104. But here you see, as the R group keep on increasing, that in water it is 104, in alcohol it is 109, in ether it is 111, but here 2 bulky groups are more bigger, bulkier, steric hindrance is too much, so more than 111, so it is 126. Direct question from NCERT, and that's why your Baba is going to take classes line by line according to NCERT. Now see, here is another question. Just see, this question is really awesome. Now, my dear students, calculate the number of sigma bonds and lone pairs. But remember that they are asking about central atom. Don't forget this, otherwise you will lose marks. Now see, xenon, I have to write xenon. So let me take XeO64 negative. XeO64 negative. So let me zoom in. XeO4, XeO, what they have given the question, XeO6, XeO6, O6, 4 negative. Now, my dear student, just see xenon, and we know that xenon, how to draw the structure. If I am drawing like this double bond O, if I make it, let me practice it, O negative, O negative, O negative, and O negative. How many bonds I have drawn? 4 negative and 6. 1, 2, 3, 4, 5, and one more 6. And let me check the valency. 1, 2, 3, 4, 5, 6, 7. It is coming 7. And how many negative? 1, 2, 3, 4, 5. So it's wrong, bhaiya, wrong, it's wrong. So in the examination, you will be in panic. So always take care of it. So let me draw once again and see, it is XeO6, 4 negative. So I should calculate that 4 negative are there and oxygen are 6. So before writing anything, just think about what you are supposed to do. 4 oxygens put negative charge. 1, 2, 3, and 4. Now mistake will not be there. Now it's absolutely correct. So always before writing, think in your brain and then solve it. Now, my dear student, what I am supposed to do? Central metal atoms, sigma bond, 1 sigma, 2 sigma, 3 sigma, 4 sigma, 5 sigma, 6 sigma, 6 sigma, and there is no lone pair, 0 lone pair. Now, my dear student, let's move towards another question. What's that question? If you see this question on your screen, this we have done. This one more question. A buffer solution is prepared by mixing ammonium hydroxide and ammonium chloride. Given that, now here also there's misprinting. They should have given that equimolar solution of this. Equimolar solution. Now if equimolar solution is given, then we can apply Henderson's-Hasselbalch equation. What is that? Henderson's-Hasselbalch equation. Let me zoom in and let me write down POH is equal to pKb plus concentration of salt upon concentration of base. Concentration of salt upon concentration of base, and their concentration is given same. Here log is missing, it's log of. Now here it's not looking good, so let me solve it on another page, clear page. Let me take clear page. This is the clear page and there is too much space, so I can use this space. Henderson's-Hasselbalch equation. Henderson, I am Harendra, he is Henderson. Hasselbalch, POH is equal to pKb plus log of concentration of salt upon concentration of base. Now, my dear students, their concentration is given same. So this log 1 will come out. Log 1 value is 0. So pKb, simply whatever the pKb was given, that is your answer. So what was the pKb? Just see, pKb was given 4.76. So definitely the answer is 4.76. If you see the answer, then the answer is 4.76. I hope you got it. It is simply the memory based question. Last but not the least, let's see. Here is the question. Maltose is a non-reducing sugar. Arey bhaiya, this is absolutely wrong. 2 days back only I taught you maltose is a reducing sugar. Why they have written non-reducing? So false. Lactose is a reducing sugar. True. Statement 1 is true and second is no. 1 is false, second is true. Now take care while statement 1 is incorrect but statement 2 is correct. So this is your answer, my dear students. Take care and remain with Baba H.S.P for your selection, government seat and rank. All the best.